Yes, keep the D. Electromagnetic induction. Electromagnetic induction. In this May, majorly we are studying about the Faraday's laws. Faraday's laws पढ़ रहे हैं. Okay. Faraday has done some experiments and he has given two laws. उसी बेस में formulas पूरा उसी में आएगा. पूरा like maximum Faraday's laws होने chapter पूरा. Okay. चलो, we will see what is happening. Okay. So to understand Faraday's laws, we are studying basically about magnetic flux. Flux के बारे में we have to learn. So magnetic flux means we represent as pi b. This is a magnetic flux. So what is the meaning of magnetic flux means the total number of magnetic field lines crossing perpendicular to surface. Suppose one surface is there, there is a magnetic field. Suppose 10 lines are coming from the magnetic field lines. Okay, all are magnetic field lines only. Those magnetic field lines which are crossing the perpendicular to the area, that is called as flux. Suppose मान लो out of 10 lines, only 3 lines are crossing perpendicularly, crossing to the cross section area. The 3 lines are called flux, remaining pura magnetic field. Okay, so total number of magnetic field lines crossing perpendicular to surface is called as magnetic flux. And magnetic flux का formula है, it is B dot A. A is a area vector, which you know already. इस सरफेस का एरिया वेक्टर ऐसा, इस सरफेस का एरिया वेक्टर परपेंडिकुलर टू सरफेस रहने का एरिया वेक्टर आपको लगाना पड़ेगा. And B is, you know, B is magnetic field. And what is the SI units? If I expand, what will you get? BA cos theta. Theta is angle between magnetic field and area vector. SI units are, SI units of flux is, tell me, this magnetic field is Tesla and area is meter square. Tesla meter square ko we call as Weber. Tesla meter square ko we call as Weber. And we have other units like 1 Weber. 1 Weber is equal to 10 power of 8 Maxwell. Other units are there, Maxwell's. So flux मालूम पड़ा ना, flux is B dot A, BA cos theta. A is a area vector. Area vector magnetic field के बीच पे angle is theta. And this formula we have to use only for uniform magnetic field. Magnetic field. Okay. No. Copy. Okay. No. It is scalar quantity है. Vector quantity नहीं है, scalar, because dot product of any two vectors is nothing but scalar. Like work is equal to F dot S किया ना, so the work is a scalar quantity. Okay. चल. Now in a non-uniform field में flux का कैसा use करेंगे? Non-uniform field है. Suppose मान लो there is a any surface, random surface, a non-uniform field है, field इधर उधर है, constant नहीं है, एक जगह में ज्यादा एक जगह में कम है. ऐसा ऐसा केस में क्या करेंगे? फ्लक्स का कैसे करेंगे? उस एरिया से स्मॉल एरिया कट करने का, स्मॉल एरिया विल कट. ओके, एंड उसका एरिया वेक्टर इज डीए एंड इसका उसमें सरफेस मैग्नेटिक फील्ड इज बी, एंगल बिटवीन थीटा. स्मॉल एरिया से कितना फ्लक्स पास कर रहे हैं बोल के स्मॉल फ्लक्स विल कैलकुलेट ऑलवेज. तो स्मॉल फ्लक्स इज डी फाइव. डी फाइव का फॉर्मूला क्या होगा? स्मॉल फ्लक्स इज बी डॉट डी ए. उस स्मॉल एरिया में मैग्नेटिक फील्ड इज कांस्टेंट बोल के मान रहा है, बी डॉट डी ए. सो टू गेट द टोटल फ्लक्स सिंपली इंटीग्रेट बोथ साइड्स. सो इंटीग्रेट बोथ साइड्स. सो फ्लक्स का फॉर्मूला है इंटीग्रल बी डॉट डी ए, एंड दिस फॉर्मूला दैट यूज व्हेन द फ्लक्स इज नॉन यूनिफॉर्म. बी डॉट डी ए इज अ फॉर्मूला फॉर फ्लक्स. मैग्नेटिक फ्लक्स को बी से रिप्रेजेंट, फ्लक्स बी. was integral B dot dA. नॉर्मल फॉर्मूला B डॉट A इज अ फॉर्मूला. तो लर्न करो फॉर्मूला बेस, अच्छा रहेगा. So BA cos theta is the formula for flux. Okay.
Sir, is that B dot DA? I mean, is the
Ah,
dot
B dot DA.
right? It's applicable for integrations, right?
Yes. Even for uniform also we can do this one. Whether multiple is uniform means B will be coming outside. Integral dA will be A, B dot A only. Okay. So non-uniform, uniform, this is a general formula. But generally uniform है तो why to go for integration? B dot A लगाएंगे. Okay. स्पेशल केस करेंगे. When theta is 0 degrees. Tell me flux, magnetic flux कितना होगा? BA cos 0, right? Cos 0 is 1. Remember BA. So this is the maximum flux. सो थीटा है आपको बहुत केयरफुल से लेने का. मैग्नेटिक फील्ड एंड एरिया वेक्टर दोनों सेम डायरेक्शन है तो थीटा इज 0 डिग्रीज. दैट टाइम फ्लक्स इज BA, दैट इज द मैक्सिमम फ्लक्स. व्हेन थीटा इज 90 degrees, मैग्नेटिक फ्लक्स विल बी cos 90 is 0, right? So it is 0. So this is the minimum flux. When magnetic field and area vector दोनों एंगल 90 degrees है तो that is called 0. Flux is 0. Done. चलो. Now flux के बारे में clarity समझ में आया. Those magnetic field, all are magnetic field lines only. Bar में रखा. It has magnetic field lines are coming. If I put a small cross section area, उस क्रॉस सेक्शन एरिया से परपेंडिकुलर क्रॉस करने वाला को फ्लक्स बोलते हैं. ओके. B डॉट A, BA cos theta is the formula. Okay. Now Faraday's experiment. Faraday has done 3 experiments. He want to conclude. अभी तक क्या था? Till now, current is coming only through battery. But he's a person who started doing the experiments and he generated through magnetic field से current generate किया. That is the thing. That is the advantage. Very that's why AC generators वगैरह all इसका principles only. Okay. तो बहुत famous person है. Okay. So first experiment. What he done is he took a magnet and a coil. Okay. Coil has a galvanometer. Galvanometer का काम क्या है? Only to sense the current. Okay. Small currents का sense करेगा. So magnetic, when I put magnet like this, simply constant, stationary, there is no current in the coil. When I bring the bar magnet inside and outside, continuously moving, that time the galvanometer is showing deflection like this, like this, like this, like this, like this. Well, indirectly current is flowing in this direction. Okay. So from this, he understood that, okay, that relative motion between magnet and a closed coil will induce electric current in the coil. The relative motion between magnet and a coil will induce a current in the coil. So compulsory stop किया तो बंद हो जा रहा है. Movement करने से only the current is flowing. That is relative motion is required बोल के he thought first experiment से. So देखो मैग्नेटिक फील्ड से करंट आ रहा है ना. मैग्नेटिक फील्ड से करंट आ रहा है. ओके. नाउ सेकंड एक्सपेरिमेंट. सेकंड एक्सपेरिमेंट क्या हो गया? सेकंड एक्सपेरिमेंट क्या है? सिमिलर टाइप ऑफ फर्स्ट एक्सपेरिमेंट जैसा कर रहा है. Instead of bar magnet, he took a current carrying coil. You know, current carrying coil generates a magnetic field, right? So curl the fingers in direction of current, thumb indicate direction of magnetic field. So again, he fixed the first coil. He moved inside and outside. Definitely the current is coming. Then he concluded that the relative motion between the coils, between the coils will induce electric current in the other coil. The relative motion, first one क्या था? Relative motion between the magnet and a coil. Now क्या है? The relative motion between two coils will generate a current in the other coil. मतलब इधर भी relative motion required बोल के he is thinking, he is doing experiments. Finally, he will conclude and he has given two laws. So I'm right neatly. कभी भी मिस हुआ तो वीडियोस देखो, अवेलेबल है. 4 महीना ओनली इज देयर. लास्ट टाइम वी डन रिवीजन. आप नहीं आया है, कोई नहीं आया है, मैं क्या करूं? ओके, चलो डन. एक्सपेरिमेंट 3. एक्सपेरिमेंट 3 क्या है? नो, इधर से बड़ा कंक्लूजन आने वाला है. ही फिक्स द कॉइल. ही इज नॉट मूविंग एनी कॉइल. नो, ही इज नॉट मूविंग एनी कॉइल. फर्स्ट कॉइल में गैलोमीटर एज इट इज. सेकंड कॉइल में बैटरी एंड की इज देयर. ओके. इनिशियली व्हेन द की इज ओपन, टेल मी हाउ मच करंट इज फ्लोइंग इन द कॉइल. हाउ मच करंट इज फ्लोइंग इन द कॉइल? इनिशियली जीरो करंट. जीरो करंट इज फ्लोइंग. ओके, देयर इज नो करंट. सो फर्स्ट ऑब्जर्वेशन देखेंगे, बाद में रीजन सोचेंगे. सो व्हाट डन इज, व्हेन ही ऑन द की ऑन करने से the galvanometer is showing deflection and coming back to zero position. That is what happening. Okay. Again, if the off the switch, again I observe here the galvanometer is showing deflection but in opposite direction. Again, it is coming back to zero position. It is not, current is not flowing continuously. Certain time तक आकर फिर से जीरो हो जा रहा है. फर्स्ट केस में क्या है? When you on the switch, suddenly the galvanometer is showing deflection. Even that is on only. Again coming back to zero position. That means no current is flowing. थोड़ा सेकंड तक only current is flowing. Okay. Again, second time में he off the switch. He observed again deflection but in opposite direction and off only is there. Again come back to zero position. Reason क्या है? देखो, when you on the switch, the current start increasing, right? मान लो the current is 10 amperes. Current flowing in this is 10 ampere. Okay. First initially zero था ना. When you on the switch, current will become 0, 1, 2, 3, 4, 5. Increase हो रहा है ना. Increase होने तो the magnetic flux which is linking to this coil. See, मान लो current is flowing like this. Curl the fingers in the direction of current. Magnetic flux will be like this, right? Linking with this coil. So when the current is increasing, the magnetic field lines will increase, which is the increasing. मतलब flux lines are changing here. When the flux lines are changing, then they observe there is the current in the flow, current in the coil. Okay. Now after certain time के बाद, the 10 ampere current is flowing now. Current is constant. Current is flowing. There is no increase in current or decrease in current. That time क्या होगा? Magnetic field lines which is linking with this coil is also constant. 10 ampere magnetic field is also constant. That time the current is coming to the zero position. No current is flowing. Okay. Again, when we off the switch, the current will change right again. 10, 9, 8, 7, 6. When the current is changing, the magnetic flux linkage is changing and the current is absorbed in the opposite direction. Okay. What will happen when you zero होने के बाद क्या होगा? There is no current, there is no magnetic field, the current is becoming zero. That means आपको major condition क्या है? Flux change important है. अगर conductor में if the flux is changing, then only the current is flowing in the coil. If there is no change in flux, the no current is absorbed. Usually, actually, he mentioned in the first law. Okay. So what is the condition here? Relative motion is not absolute requirement, but the change in magnetic flux is required. Very important. Without change in magnetic flux, there is no current. then he gave the Faraday's laws. First law is the theoretical one, second law is the numerical based. Questions उधर से आएगा questions. Okay, चलो. Faraday's laws of electromagnetic induction. You want to write? Right. Teresa? Yeah. Faraday's laws of electromagnetic induction. So first law क्या बोला? That whenever there is a change in magnetic flux, very important, whenever there is a change in magnetic flux linked with the conductor, an EMF is induced in the coil. EMF is nothing but voltage, electromotive force they'll call. Okay, EMF is induced in the conductor if the conductor is closed. If the conductor is closed, current is induced. Current is induced in a coil. Current is induced in the coil. So whenever there is a change in magnetic flux, the current is induced in the coil. That is an important thing we have to know. If there is no change in flux, there is no current. In the first experiment mein also, the bar magnet is moving front and back, then the flux linkage is changing, then only the current is getting produced. So flux is important. You know, nowadays they are keeping in other countries में they are keeping in generator में मालूम है ना, AC जनरेटर का बेसिक प्रिंसिपल क्या है? आपको घुमाना पड़ेगा. जनरली क्या होगा, आगे पढ़ने वाला है. So this is the north pole south pole. देखो 10th क्लास में पढ़ा होगा ना. There is a coil. Okay, there is a brushes will be there. Slip rings will be there like this and will generate electric current. Okay, resistance load में आएगा. So magnetic field में the coil को घुमाना पड़ेगा, ऐसा घुमाना पड़ेगा, zoom go. Okay, then only the current is getting produced. AC center आगे बढ़ने वाला है. Okay, so nowadays what they will do, जिम में they'll put ये setup आपको जिम में साइकिलिंग में लगाएगा. The persons who are coming they go on cycling वो उसमें क्या होगा, current is getting generated and battery is getting charged. So क्या होगा, automatically some like night में और some में lights के लिए they will use that no power, मतलब generate कर सकते हैं. सब लोग वो लोग ही generate कर रहे हैं. So much they are putting. Even Japan में what they will do, they will put a speed breakers के नीचे setup they put this setup. क्या होगा, when the vehicles are going, नीचे प्रेस करेगा वो स्पीड ब्रेकर वाला, थोड़ा नीचे प्रेस करेगा. प्रेस करने से क्या होगा, वो इनसाइड एक सर्कुलेशन घूमेगा, करंट इज गेटिंग जनरेटेड एंड इट्स गेटिंग स्टोर्ड. सो हाई ट्रैफिक होता जाएगा, कंटिन्यूस रोटेट होता जाएगा. दे विल यूज दिस इन द स्ट्रीट लाइट्स, नाइट में नो पावर नथिंग. सो ये इतना इंपॉर्टेंस है. सो मेजर थिंग इज फ्लक्स को चेंज करने का. ये फ्लक्स चेंज हो रहा है भाई. इनिशियली ऐसा था, मैग्नेटिक फील्ड लाइंस ऐसा था, बाद में रोटेट किया, बाद में जीरो हो गया, अगेन मैक्सिमम फील्ड लाइंस आर पासिंग. Okay, flux lines are passing. Matlab, whenever there is a change in flux is happening, whenever there is a change in flux, the current is getting induced in the coil. That is the Faraday's law, first law. Now the question is how much, how to calculate kitna EMF is how much, EMF is voltage is how much, current is how much, we have to know, right? So uske liye second law is given. Second law says the magnitude of induced EMF in the circuit is equal to time rate of change of magnetic flux through the circuit. So what is saying, EMF, average induced EMF, mod I am putting, magnitude of induced EMF is mod time rate of change of flux. Time rate of change of flux means delta phi by delta t. This is the formula for EMF induced. Mod डेल्टा फाइव बाय डेल्टा टी. मॉड भी मालूम है ना, लो अंदर नेगेटिव में आ रहे तो पॉजिटिव डालने का. एंड न्यूमेरिकल्स में वी आर यूजिंग ऑलवेज मैग्नीट्यूड ओनली, नो दिस वन, नेगेटिव नहीं आएगा. ओके, ई इंस्टेंटेनियस फॉर्मूला विल बी मॉड डी फाइव बाय डी टी. EMF voltage will be induced in the coil. How much means ये वाला, अगर flux in terms of time is given to differentiate to get instantaneous. They will tell at 10 seconds में what is the value, ऐसा पूछे तो we have to differentiate instantaneous value. Okay, and suppose they will ask current कितना, suppose closed coil current is how much, you already found the E, right? Either this method or this method. So simply I is equal to E by R, Ohm's law, P equal to IR, I equal to E by R use किया तो we'll get a current. And you know how to find flux. That's why we learned about flux initially. BA cos theta. B dot A, BA cos theta values. Okay. But actual formula will be actually, if you remove mod, actual formula क्या रहेगा मतलब? E average. Suppose. If I remove mod, minus आएगा. Minus delta phi by delta t. This is for only for one coil. अगर n टर्न्स है तो n से मल्टीप्लाई करने का. So this is the actual formula. Minus is because of Lenz law. आपको आगे आएगा Lenz law. But न्यूमेरिकल्स करने समय we should not use any minus. Simply आपको mod कैलकुलेट करना पड़ेगा. Simply delta phi by delta t. Mod delta phi by delta t. Minus is to indicate the direction of the EMF in current direction कितना है बोल के दिखाने के लिए minus. Okay. दिस ऑल वन कॉइल के लिए. अगर n टर्न्स है तो n से मल्टीप्लाई करना पड़ेगा कंपल्सरी. ओके. सो ईएमएफ का फॉर्मूला आ गया ना. ईएमएफ फॉर्मूला बोलो. ईएमएफ इज इक्वल टू मॉड डेल्टा फाई बाय डेल्टा टी. डेल्टा फाई मीन्स व्हाट? चेंज इन फ्लक्स. फाइनल फ्लक्स माइनस इनिशियल फ्लक्स. फाइनल आपको याद रखने का, इनिशियली मैग्नेटिक फील्ड एंड एरिया वेक्टर सेम डायरेक्शन लेने का ऑलवेज. मैग्नेटिक फील्ड एंड एरिया वेक्टर सेम डायरेक्शन ले लो. एंगल इज जीरो. Always whenever you don't mention the coil is there ऐसा बोले तो initially magnetic field which direction है उसी direction में area vector लेने का. And finally he will tell, he will rotate 90 degrees 180 he will tell coil को उसका angle लगाने का. Angle between magnetic field and area vector. फॉर्मूला क्या ना? मॉड डेल्टा फाई बाय डेल्टा टी. यही फॉर्मूला पे बहुत पूरा 90% ऑफ द चैप्टर्स में यही होगा टोटली. फैराडेज लॉ ओनली पूरा. ओके. मॉड डेल्टा फाई बाय डेल्टा टी एंड डी फाई बाय डी टी इज अ फॉर्मूला. ओके. फ्लक्स को चेंज करने का तरीका विल सी. हाउ टू चेंज द फ्लक्स. ओके. फ्लक्स को तरीका है. वन थिंग इज मैग्नेटिक फील्ड चेंज करो. देखो, दिस इज मैग्नेटिक फील्ड. मैग्नेटिक फील्ड इज इनवर्स, राइट? इनवर्स इज क्रॉस, राइट? आई पुट ए कॉइल. ओके. नाउ बी इज चेंजिंग. Magnetic field is changing means flux is changing or not? Flux lines are changing. Magnetic field lines are changing means flux linkage is changing. So this is the method to change the flux. Or other method क्या है? Suppose this is a coil. Okay. I am increasing the coil. I am increasing the radius of the coil. So radius of the coil means area is increasing, right? If the area is increasing, the flux lines are changing. Even the magnetic field lines are there. Before 3 था, बाद में increase होता 4 हो जाएगा. So here area is changing. Because radius is changing means area is also changing. So area से भी flux linkage change होगा. और दूसरा मेथड है. The coil is there. Okay. Diameter के about I am rotating with angular velocity omega. Okay. इस वाले एसी में ये आएगा. एसी जनरेटर में ये आएगा. ऐसा था, ऐसा घुमा रहा हूँ. जुम 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 बोल के घुमा रहा हूँ. घुमाने से क्या होगा? फ्लक्स इज चेंजिंग. डेफिनेटली फ्लक्स इज चेंजिंग. सो फ्लक्स इज चेंजिंग मींस हियर व्हाट इज हैपनिंग इनडायरेक्टली. देखो, इनिशियली मान लो मैग्नेटिक फील्ड एंड एरिया वेक्टर इज इन द सेम डायरेक्शन. एंगल इज 0 डिग्रीज. बाद में कॉइल जब घूमेगा ना, एरिया वेक्टर इज चेंजिंग. मतलब हियर व्हाट इज चेंजिंग? थीटा इज चेंजिंग. व्हेन थीटा इज चेंजिंग, theta is angle between magnetic field and area vector. When theta is changing, the flux lines are changing. Therefore क्या होगा? Current is getting induced in the coil. Okay, these are the methods. Okay, so that's theta changing. So we learn the formula EMF induced, instantaneous EMF, and current का formula is E by R. Okay, चलो. Can you able to hear? Yeah. Chalo. A magnetic flux is perpendicular to the plane. He is telling 5 values given. Okay, 5 in terms of time is given. 5t cube plus 4t square plus 2t minus 5. Calculate the induced current through the coil at 2 seconds. Matlab he is asking instantaneous wala. Okay. So current is asking, right? We know this formula. I is equal to E by R. Resistance also given. Now E find karo by instantaneous ka and substitute at t equal 2 seconds and get the answer. EMF ka units are volts. Instantaneous formula. Mod लगाने का. Mod is mod d5 by dt. Differentiate and at t equal 2 seconds लगाओ and current find करो.
15.6.
Yes, 15.6 amperes. Yeah. So differentiate किया श्रीराम. देखो 5 को बाहर how much you got volts श्रीराम?
15.6.
EMF कितना है? I want to check.
So EMF about 78.
Oh, very good. 78 volts. Now current is 78 by 5 किया था 15.6 amperes is answer. Okay. चलो. Next. A coil of area this much having 1000 turns. देखो turns is given now. Is suspended perpendicular to magnetic field. Okay. देखो magnetic field ऐसा है into the page है. A coil is there. देखो they are perpendicular only. देखो if you see carefully, this is in xy plane. The coil is in xy plane, and magnetic field is along z axis. So they are perpendicular. Okay, that's why they suspended perpendicular to the magnetic field. मतलब this is arrangement. Initially ऐसा था. बाद में क्या किया? It is rotated 90 degrees in 0.2 seconds. 90 degrees means ऐसा पहले ऐसा था, बाद में ऐसे घुमाया. Okay, so magnetic field तो सेम है. मैग्नेटिक फील्ड तो सेम है. कॉइल को घुमा रहा हूं. हमारा इंटेंशन क्या है? फ्लक्स चेंज करने का. दैट्स इट. कॉइल को घुमाया. नाउ एरिया वेक्टर इज ऐसा एंड मैग्नेटिक फील्ड इज ऐसा. सो इनिशियली थीटा इज हाउ मच? थीटा इज, आई टोल्ड यू, मैग्नेटिक फील्ड के डायरेक्शन में वी शुड टेक एरिया वेक्टर, मैग्नेटिक फील्ड दोनों सेम डायरेक्शन है. सो एंगल इज 0 degrees. And here the given theta is 90 degrees because magnetic field lines and area दोनों perpendicular है. Okay, now find, he's telling to find average induced EMF is how much? Average induced EMF.
10 power minus 5.
10 power minus 5. But we have to multiply with turns also. N
No.
times. If for one coil only we are using, right? Multiply that.
10 power minus 2.
Oh, yes, correct. So EMF average induced EMF formula we know, right? Average induced EMF is mod delta phi by delta t. So final flux तो 0 है, minus initial flux is BA. Since our n turns are there, NBA by delta t is 0.2 seconds mod. So substitute the values, we'll get the EMF induced. So answer is 10 power of minus 2 volts or 0.01 volts. Okay. आया समझ में श्रीराम? Delta phi by delta t. Okay. All our values are given. N value, A value, B value, T value is given. Substitute. Okay. नाउ क्वेश्चन डिफरेंशिएशन करने समय आपको रिमेंबर करने का, सपोज मान लो you have x square. I want to differentiate y equal to x square, suppose. Okay, I want to differentiate dy by dx and dy by dt. Tell me, ये कितना है, ये कितना? And x is a function of time. X is a function of time. Then इसका आंसर तो क्या है? dy by dx is 2x. Now dy by dt is how much? dy by dt is how much?
2x
मतलब
dx by dt.
yes. Whenever you are doing differentiation which is not in, देखो x का only करने का, right? x का t times में कर रहे हैं and x is depending on time. That time क्या कैसे करेगा? 2x differentiation करके into dx by dt करने का. Always extra term will be coming. Okay, tell me, y is equal to x cube. Tell me Sriram, dy by dt suppose will be n into x power n minus 1. So 3x square
dx by
into dx by dt. ऐसा करना है. Whenever you differentiating with respect to some other things. Okay, चलो. A conducting circular coil is placed in a uniform magnetic field such that its plane is perpendicular to the field strength 0.5. Okay, so same plane is perpendicular to magnetic field. So this is a magnetic field. Magnetic field is inverse and coil is there which is perpendicular to the magnetic field, and everything is given magnetic field. Its radius, if the radius of the coil is decreased at a rate of 10 power of minus 2 meters per second, हर सेकंड में इसका radius is getting decreased. मतलब slowly it is decreasing. The radius is getting decreased. Okay, हर सेकंड में. What is given study at a rate of 10 power minus 2 means dr by dt. Radius is decreasing with respect to time is 10 power of minus 2 meters per second. This is given. What will be the magnitude of induced EMF when the radius is 7 centimeters? ये decrease करके at the 7 centimeters जब आएगा ना, ये उस time में induced EMF कितना है? Induced voltage is how much? Okay, since we know dr by dt differentiation करना पड़ेगा, right? He's asking magnitude of induced EMF. So which one will use? Incidence का use, right? Incidence का mod is equal to d phi by dt. mod. So उसका फ्लक्स चाहिए कंपल्सरी. सो फ्लक्स का फॉर्मूला क्या है? बी ए कॉस एंगल कितना है? एंगल कितना है? हियर इनिशियल आई टोल्ड यू मैग्नेटिक फील्ड area vector should be taken in the same direction. So angle is 0. So cos 0. So BA. You got answer, Satvik?
7 into 10 power minus 4.
7 into 10 power minus 4. Wrong. Okay. You also got the same answer? No. Okay. BA cos 0. Okay. Now area is how much? Area of the coil is pi r square. Initial radius मान लो r. Radius is pi r square. Is the radius initially? Flux है ना? हाँ. Now आपको क्या चाहिए? d phi by dt कर देन ऑल इंसिडेंस आ जाएगा. Okay. So d phi by dt we are doing. Then only we'll get the EMF, right? Mod. Incidence का mod. Okay. So क्या होगा? B is constant, pi is constant. B बाहर आ जाएगा, pi बाहर आ जाएगा. And difference see R we are differentiating with respect to time. So उसका how to write? 2R into dr by dt. Right? Mod. So substitute the value. R value is 7 centimeters, 7 in 10 power minus 2. dr by dt already you know. Pi value you know. B value you know. Everything value you know. Substitute, you get the answer. Pi 22 by 7 ले लो हो जाएगा. Because 7 centimeters है ना, cancel हो जाएगा. हाँ,
22 into 10 power minus 4.
हाँ, 22 into 10 power minus 4. So whenever a radius is decreasing, area is changing, flux lines are changing, EMF will be induced definitely. उसमें कितना EMF induce होगा बोल तो ऐसा मेथड करना है. pi r square. सर्कल है ना pi r square. So Faraday's law only पूरा चैप्टर पूरा Faraday's law only. न्यूमेरिकल भर के आएगा क्वेश्चंस पूरा. Faraday's law समझो इजी. एंड बीच में एक दो क्लास नहीं आए तो क्लास ये कुछ भी समझ में नहीं आएगा. व्हाट इज गोइंग ऑन, ये चैप्टर छोड़ देंगे बोल के लगेगा. So try to listen properly and while coming read the formulas and come. Okay. चलो next. थोड़ा हार्ड क्वेश्चन करें.
So
Okay.
the answer was 22 into 10 power minus 4, right?
22 into 10 power minus 4.
Right.
So 22 into 10 power minus 4 volts. चलो हार्ड क्वेश्चन करेंगे. A structure formed by two straight conducting rods forming a right angle is placed. Forming a right angle, देखो, is forming a right angle 90 degrees. A two rods here which is forming 90 degrees. Okay, is placed in uniform manifold. Uniform manifold is coming towards you now. Dots are there, is coming towards you. Manifold is given right out of the page. Okay, a straight connecting bar in contact with the structure starts at t equal 0. एक रॉड है, स्ट्रेट कनेक्टिंग रॉड है, इनिशियली टी टाइम टी इक्वल 0 में मूव करना स्टार्ट हो गया. उसके ऊपर वी शेप लगा, मूव ऐसा पकड़ के लेके जा रहे हैं. ओके, स्टार्ट एट ए वर्टेक्स टी इक्वल 0 एंड मूव्स एट ए कांस्टेंट वेलोसिटी 5 मीटर्स पर सेकंड. कांस्टेंट वेलोसिटी 5 मीटर्स पर सेकंड से जा रहा है ये रॉड, जूम बोल के जा रहा है. कैलकुलेट द ईएमएफ अराउंड द ट्रायंगल एट टी इक्वल 4 सेकंड्स. मतलब व्हेन द रॉड केम, मान लो अप टू 4 सेकंड्स के बाद ये तक आया. At that time, EMF is induced around the triangle is how much? So definitely देखो, when the rod is here, मान लो, suppose there is a small triangle, right? Flux lines are small. When the rod is increasing, the flux lines are increasing, EMF will be induced. Whenever there is a closed, the current is also produced. So indirectly, he is forming a closed structure by moving the rod. ओके, एक ही रॉड है, ये दो रॉड नहीं, इधर से स्टार्ट हुआ, जुम बोल के जा रहे हैं. एट 4 सेकंड्स में ईएमएफ इंड्यूस कितना है इन दिस ट्रायंगल में आस्किंग. ओके, सो सेम मेथड है, सॉल्व कर सकते हो, सॉल्व करो. फाइंड द वैल्यू ऑफ ईएमएफ इंड्यूस्ड. वी नो द फार्मूला फॉर ईएमएफ इंड्यूस्ड. व्हाट इज द फार्मूला? E is equal to, he is asking at t equal 4 second, right? At the time t equal 4, instantaneous यूज करेंगे. E instantaneous is equal to mod d phi by dt. फ्लक्स चेंज करने का, कितना फ्लक्स चेंज होगा उतना ही ईएमएफ आएगा. सो फ्लक्स पर डिपेंड होगा ऑलवेज. सो फ्लक्स का फॉर्मूला है बी ए. आई इनिशियली आई एम अज्यूमिंग a magnetic field, area vector, both are in the same direction, angle is 0, cos 0. Okay, now magnetic field तो दे दिया, area कैसे आएगा? Area is important for us. Okay, area in terms of velocity and time में चाहिए. Velocity is given, time also given, right? Velocity time में चाहिए. Okay, suppose मान लो इधर से तक distance d है. Exactly, I'm drawing one perpendicular bisector. Okay, this is d. D is the distance. This angle is how much? This angle is how much? This angle will be perpendicular bisector है ना, 45. This also 45. And this is 90. Right? Okay. If this is 45, this is 45 means this is also 45. This is also 45. Right? Maths I'm applying. Now tell me, ये याद है, when two in this triangle में, when two angles are equal, then opposite sides are equal, right? तो क्या होगा? इसका opposite side is D, इसका opposite also D. Similarly, इसका दोनों opposite angles are, इसका in this triangle में, if two angles are equal, opposite angles are equal. इसका opposite D, इसका opposite D. So ये वाला भी D है, A वाला भी D है, A भी D है, right? Now इसका एरिया कितना होगा? एरिया ऑफ दिस ट्राइंगल. ये ट्राइंगल का एरिया फाइंड करो. एरिया ऑफ ट्राइंगल, एरिया ऑफ ट्राइंगल. बिकॉज इफ आई नो द एरिया ऑफ ट्राइंगल देन ओनली आई कैन सब्स्टिट्यूट हियर. हाफ इनटू बेस. बेस कितना है? 2d इनटू हाइट. हाइट ऑफ द ट्राइंगल इज d. तो 2 कैंसिल, d स्क्वायर आया, राइट? एरिया वी गॉट एज d स्क्वायर. d आप हमने लगाया, we did, but d is not given. Okay, so b into area is d square you got. Cos 0 is 1. Okay, a distance है ना, d is a distance from here to here, right? Distance, speed and time का relationship मालूम है ना? Speed is equal distance by time, distance equal speed in time. So substitute करो b into v into t whole square is p square t square. तो फ्लक्स आपको क्या आया, फ्लक्स आ गया, रेडी हो गया फ्लक्स का. नाउ d5/dt करो, टाइम वेरी हो रहा है ना, टाइम अंदर रखो. सो E instantaneous is equal to d5/dt. When you differentiate, b will be coming, b is moving with constant velocity, वो भी बाहर आ जाएगा, b square d by dt of t square, so which is 2t. So b v square into 2t. So substitute the value and tell the answer. b v square into 2t is the EMF induced. Now velocity is given, time is given 4 seconds, b value also given 0.4 Tesla.
Sir, 80.
80 volts. Okay, Shamaya. Next. Now one more formula आएगा, induced charge. Induced charge बोल के. So EMF का we learn, current we learn. Two formulas. Now third one is induced charge. देखो EMF का फॉर्मूला क्या था, mod is equal to mod d phi by dt. And current का, because charge आने के लिए current से will get charge. So current का we are trying to find. Induced current का फॉर्मूला क्या था, E by R. So 1 by R, E के जगह में mod d phi by dt. I want in terms of charge, right? Charge है. I is equal dq by dt again, right? Rate of flow of charge is called current. 1 by R mod d phi by dt. dt cancel. So dq is equal to d phi by R. Right. Now I am integrating both sides. Either q1 to q2, either phi1 to phi2. Okay. So upper limit minus lower limit. So q2 minus q1. I call it as delta q. देखो integration of dq is q. Upper limit minus lower limit किया तो q2 minus q1 is called delta q. So delta q is equal to and a small q लगाएंगे. Delta q is equal to ये 1 by r बाहर आ जाएगा. Integration d phi is phi. Phi2 minus phi by को delta phi बोलते हैं. So delta phi by r. This is a formula. Induced charge is equal to delta phi by r. देखो इधर भी डेल्टा फाई फाइंड करने का, फाइनल फ्लक्स माइनस इनिशियल फ्लक्स, देन डिस्टेंस r is the distance. Whether delta q is depending on time interval, it does not depend on time interval. आप कोई भी टाइम में इतना इंड्यूस चार्ज को उतना चार्ज तो रहेगा इंड्यूस चार्ज तो. ओके same method we are learning. Faraday's law, third formula we got, delta phi by r. Okay, चलो क्वेश्चन करो. क्वेश्चन थोड़ा बड़ा लेंदी रहेगा बट सेम ओनली. A small coil is introduced between the poles of the magnet so that axis coincides with the magnetic field direction. मतलब क्या है, मीनिंग क्या है, a small coil is introduced between the poles of the electromagnet. So this is a pole, north pole, south pole, such that axis coincides with the magnetic field direction. The magnetic field direction is like this, right? So axis, the coil is also like this. Area vector is like this. इसके axis coincides with the magnetic axis. Okay. The number of turns is n. Small n बोला, number of turns. ठीक है, जो दिया वो डालेंगे. Cross section of the area of the coil is A. Okay. When the coil turns 180 degrees about its diameter. Now क्या किया? Magnetic field तो same है. Magnetic field तो we are not changing. 180 degrees turn किया before. ऐसा था. 180 degrees means exactly opposite direction में घुमाया. So मैं coil को घुमाया. ऐसा घुमाया. Area vector now got changed to like this. Now tell me angle between magnetic field and area vector is 180. Right? इधर change किया. About the diameter. The charge flowing through the coil is Q. मतलब delta Q का he told to take Q. The total resistance is R. He is telling to find magnitude of magnetic induction. मतलब B value is how much? Magnetic induction is B is how much? So डरने का नहीं, induced charge बोल के दिया ना, hint दिया ना, induced charge का formula use करो. From that maybe you will get B. So delta Q का formula क्या था? Mod delta phi by R. Now find change in flux in terms of variables में आएगा. And mod only. Delta phi you should take as mod always. If you calculate mod only. Delta phi is final flux minus initial flux. Final flux will be how much? Final flux is
Delta Q R by 2A.
हाँ
Delta Q R by 2A.
हाँ डेल्टा क्यू को क्यू ले लो.
Q R by 2A.
एन मिसिंग है, एन भी रहेगा ना, नंबर ऑफ टर्न्स दिया ना. ओके फाइनल फ्लक्स कितना है? फाइनल फ्लक्स इज बी ए cos 180. cos 180 is -1. So minus and n turns are there, right? So minus NBA. Okay. Final flux minus initial flux. Initial flux both are same direction. NBA by R. देखो B आ रहा है ना from this delta Q को Q माना. So here minus NBA minus 2 NBA और मैग्नीट्यूड निकालने से क्या होगा? बाहर निकालने से 2 NBA by R. Therefore, is asking B, right? B is equal to QR by 2 NA. QR by 2 NA is answer. So चार्ज बोल के दिया ना, सो ठीक है. बैड फील्ड सडनली बैड फील्ड पूछे तो इधर से बैड फील्ड कैसा पूछेगा, ऐसा नहीं. आपको डेल्टा क्यू से आने का आ जाएगा, सब्स्टिट्यूट किया तो आ जाएगा. ओके और जेईई मेंस क्वेश्चन करो, क्वेश्चन हाँ करो. नाउ द ग्राफ इज गिवन, करंट का एंड टाइम का ग्राफ इज गिवन. 10 to time is 0.5 seconds. If the coil of resistance is given, current is induced by changing magnetic flux. So in some condition में magnetic flux is changing, उसका current is changing like this. Okay, he's telling the magnitude of magnetic flux through the coil is how much? Flux through the coil is how much? Flux phi is asking. Mod delta phi is asking. I want change in flux through the coil is how much? I'll give options.
So 200.
No, wrong. White 200.
I got something
Okay.
close to that.
जेईई में क्वेश्चन अच्छे से करो. देखो करंट टाइम ग्राफ इज गिवन. फ्रॉम दिस आई कैन फाइंड चार्ज. करंट टाइम ग्राफ से चार्ज कैसा आएगा? हाउ टू फाइंड द चार्ज? एरिया अंडर द ग्राफ. सो आई कैन यूज डेल्टा क्यू फॉर्मूला. डेल्टा क्यू इज इक्वल टू डेल्टा फाई बाय आर. बिकॉज रेजिस्टेंस इज गिवन, इज आस्किंग चेंज इन फ्लक्स. सो इससे रिलेटेड वाला डेल्टा क्यू है. एरिया फाइंड करो. एरिया अंडर द ग्राफ विल गिव द डेल्टा क्यू टाइम ग्राफ, राइट? सो कितना होगा? half into base is 0.5 into height is 10 into r कितना है 100 ohms is equal delta phi. So 500 by 2 is 250. So 250 Webers is a formula for flux. Yeah? So easy question only. Finished? So these are the things in the Faraday's laws. Next we have to go for the Lenz law जाना पड़ेगा. Lenz law and वो Lenz law use करके again we are using the Faraday's law से questions करने वाला है next class में हम लोग.